Okay, so hello everybody. This talk will be about the new PHP Opcache. You should know about this because I guess you read the news and you read Twitter and things like that. So first of all, I'm Julien. I'm working for Synthio Labs in Paris. I'm French, so I apologize for my English wordings, sometimes missing or things like that, but I guess you'll understand my talk anyway. So I've been programming in PHP for now more than 10 years, something like that. And I wanted to give back to open source what open source gave to me because I think this is the challenge. So now I'm a PHP internal reviewer and developer, so I'm trying to make PHP better every day, even if it's not pretty easy. I'm PHP 5.5 and 5.6 release manager, and we are talking about PHP 6 actually on mailing list. More to come later about this. I wanted to document the PHP internals code because PHP internals code, which is C code, has no documentation at all, or a pretty tiny one. So I'm actually writing phpinternalsbook.com together with other PHP contributor to try to make people know how PHP works internally and things like that. So this is a free book, actually. You can go on the URL and fetch it if you want. What we'll cover together, we will remind you how PHP works internally. So perhaps some of you have attended Davy's talk this morning, just before lunch. So pretty things in common with my talk. Anyway, we're going to talk and focus on OPCodes and the need to have an OPCode cache, what the solutions we had before, yes, APC and things like that, what we have now, Opcache, what's the difference between them from a developer point of view and from a system administrator point of view, what you should do when you put code to production with Opcache and what you should not do or prevent to do, and how you can configure it for production. So we will review the configuration settings and how to set them up. And benchmarks. I don't have benchmarks, actually, so why is this wording here? No, Opcache has been a Zend internal product for years, and they recently open sourced it and gave it to the PHP community, and they gave it to PHP, so we merged it in PHP 5.5. So it's a very, very old product, which means it's been developed with lots of experience, so it's nowadays pretty stable. Okay, it's a pretty nice product. So Zend had benchmark. They still have benchmarks you can find on the web. Anyway, benchmarks are just about Hello World sometimes, so it's not really relevant. But anyway, you can find some on the web. So first of all, what is PHP? So you know PHP. PHP, it's a scripting language, so you can read this everywhere. So what's a scripting language first? It's a language which does not require you to compile it. It compiles itself. Okay, it compiles its own code to an intermediate bytecode, and the bytecode is executed later by the virtual machine. We'll talk about this later. In later slides, highly dynamic, highly extensible. The first term is really important. It's that PHP is highly dynamic. You can create classes on the fly, which is something when you try to optimize the opcode down in the low level, this is pretty hard. And you have no typing about your variables. So when we compile the code, we cannot really guess what type you're using so that we can make optimization internally. So OPCode, Opcache is something which tries to optimize your code, and it gives some trade-off. I assume you're doing this, but I should really be sure, because if I optimize something wrong, then your code will just not run and not do what you want. So this is nice for PHP to be highly dynamic, but this is pretty hard internally to handle this in the engine, because everything can be everything at every time. So that's pretty hard to optimize internally. So how does PHP work? You should know now that PHP code first comes into a parse phase. The parse phase is, can be split up into two little phases, which is lexing and parsing. Okay, we'll talk about this later. Then from the parser, you get nodes, and those nodes are given in a compiler, which generates OPCodes, and the OPCodes are then passed to the upper layer, which is the virtual machine executor. And the virtual machine executor is going to execute these opcodes and give you a result, which is usually something which is printed on standard output. This is the main PHP, how PHP works mainly. So this is pretty long definition of what is a virtual machine. I'm meaning a software virtual machine. Okay, we're not talking at all about virtualization of the hardware. It's not the point here. So a virtual machine is just a system over the system which tries to run over many different hardwares and many different platforms and operating systems, because operating systems are very different from each other. Should you take Microsoft ones and Unix, just those two bigs, they are very different, and PHP has to run the same way on those systems, which is a day-to-day challenge for us developers into PHP, because we have to support lots of platforms. So that's exactly the same as every scripting language. So Python, Ruby, we can even talk about Java. They work the same way PHP works. Okay, there are little things which are different. I mean, in Java, you compile yourself your code. You just don't run code and then Java is going to compile it for you. But it's exactly the same internally. They all use heavily what is called a virtual machine. Okay. So the PHP way is compile, execute, forget, compile, execute, forget. You know about this. So when a request comes in PHP, it's treated. So PHP is going to compile, execute, and stuff like that. And then it's going to forget everything, every classes it met, every variables, every file you open, every resources. It's going to throw all this away, free memory, and just get ready for the next request. So the next request doesn't know anything about the previous request, and this is why PHP scales very nicely, because you just have to multiply the PHP workers, and then there is no context, there is no server context like in Java, and this can be a drawback, but this can be as well an advantage, so we take it as an advantage here. So we pass the code, we compile the code, and then we execute the code. But what happens, and we throw away all we've done so far for the next request. So what happens when you want to run the same file twice or several times, where PHP will still, again, parse and compile your script before executing it. So the problem is that if your script have not changed between two requests, which is much likely the scenario, then you're going to parse and you're going to compile your code again and again and again, and parsing and compiling can really take time. This is why we use Opcache. So usually, I hope that execute time is much higher than compile time, okay? But it can happen that compile time can be very hard, very heavy, because when we compile the code, we do lots of things, and lots of big things we just don't care about. At this stage, we just don't care about CPU cycles and memory. We just do all we can do so that we will have an execution phase which is as tiny as possible in response time, okay? So when you compile a PHP script, it actually can take much time. This is an example where I dumped the times in the engine. And on this one, while executing a script, we can see here, this is an example like many to come. It took about a quarter of the time to compile the file, compile, and the 3 other quarters to execute it. Okay, so this is not transparent. This is not the compile time can really put your server down because you compile many files and many things like that. And when you parse the code, you execute lots of functions in C and things like that, which can really take much time. So what you want to do is that you want to prevent PHP from parsing again and again and again the same files. Okay, so you will use what we call an Opcache and an OPCode cache, and when PHP is run with an OPCode cache, it is really similar to Java at this time because it just does not compile code anymore. All is in memory, all is executed again and again, which is something very similar with Java. So that's the point. So, when classes are interesting because when PHP, when you run a file which just declares a class, you will compile a class and you will execute nothing. Because declaring a class, if you don't create an object or use it, you will have a very high compile time, but a 0 execution time, and then PHP will throw away all the opcodes from the class and then pass it again at the next request. So when you don't use an opcode cache, so that's important. And whenever you use include, require, eval, or the autoload, you just defer a compile while executing. This means that when PHP passes a file, it just passes it, it transfers to OPCode, and then it executes it. And when it has to execute an OPCode which says, oh, include this file, it just stops the current execution and run again, compiling the file you just included, and then execute it. And this file probably has other include inside, so throw this on the stack away, and then get the next file, compile it, execute it. No more include, no more eval, no more autoload. Okay, let's go back, resuming what we were doing before. Okay, this is pretty different from a compiled language where at compile time everything is checked. Okay, this is not the case with include and require, for example, because if the file does not exist, you will hit an error at runtime and not at compile time. Okay, this is how PHP has been designed lots of years ago now. So this is how it actually works. So what can we do when we pass, compile, and execute? Is that we can actually try to cache the OPCodes, which are given from the parsing of a single file or a string when you use eval. And we can cache this to shared memory, okay? So that later on, when another process of the same pool will require the same file, we just load the opcodes from the shared memory if the file has not changed. And I guess in production, until you deploy, you don't change files many often on production servers. So we just read the OPCode back from the shared memory, and we just feed the virtual machine with those OPCodes, and all the parsing time and the optimization time has been prevented, and then you have a PHP which is pretty speedy, and you can expect to have to be able to handle tons of requests per second, because at least on the latest versions of PHP, it's pretty well optimized nowadays. It has nothing to do with what were PHP 3 and PHP 4. It has very evolved in a very nice way. Okay, so what we can do as well, and this is what Opcache does, and this is what is interesting, and this is what I've been working on, is you have OPCodes, and before caching them, what you can do is run functions which will try to optimize the tree of the opcodes. For example, if you have an if false all the OPCodes from the false branch will never be run, so you can just throw them away and have a smaller OPCode array, so you have a smaller memory footprint when you run PHP. This is an example, and you have lots of them while using an optimizer. So Opcache comes by default, you have nothing to do, with an optimizer, and what APC does not. Actually, APC is just, this is to be taken care of, this is just an OPCode cache. Opcache is together an OPCode cache together with an optimizer, and the optimizer does many nice things for your code. I will show you later. So let's now, unfortunately, if I can say, explain what OPCodes are. So again, Wikipedia is very nice. So OPCodes are just what is given the virtual machine so that it can actually execute them. So you can have OPCodes like add, which is just having a plus and add function. You can have OPCode if you use the point. The compiler will generate an OPCode which is called concat. Okay, which takes two operands, OP1 and OP2, and gives a result, which is just the concatenation, which is pretty easy to do in C. It's just a mem copy. If you have strings, if you don't have strings, then PHP and the virtual machine is going to translate them to strings, and then just mem copy, and then give this result to the line after. So you have lots of OPCodes. Actually, we have more than 100. We have many of them. So everything you do when you call a function, when you do an if, you generate, each time you generate an OPCode. An if is just something which will evaluate an expression, and if the expression is true or false, it will generate a jump if 0. So if the result is 0, it will jump to another opcode. If it's not 0, it will jump to another one, and you have an if structure, which is pretty easy to do. Okay, so this is actually OPCodes in PHP 5.4. They are the same in 5.5. I don't know about 5.6, but I think they are the same as well. They have been, many times they have been rewritten. And you don't know this when you use PHP, but for example, from 5.3 to 5.4, all this has changed. This means that those structures are absolutely invalid for PHP 5.3 and less. This is starting from 5.4. This is why when you want to use Zend extensions and extensions which actually play with opcodes, you have to recompile them and you have to patch them to take care of the new OPCode structures. So as you can see, this is like a calculator. You know, you have OP1 and OP2. Okay, you have a handler. Okay, the handler is actually the function which will be executed with OP1 and OP2, and it will give a result. And probably it could need an extended value. Extended value is something like the carry. You know, when you add two numbers and you multiply them, you can have a carry. So this will be put in actually extended value, and then the types. And the nodes, so actually the operand and the result are nodes, and nodes can be constant variables, numbers, hashes, or jump address, which is used when you talk about if, while, switch, and things like that. Okay, so this is C code, and that's it. That's how it works actually. So let's see examples of OPCode, and let's see how Opcache can interact with that and optimize that in a pretty nice way. So this is a silly example, like you every time you see conferences, because we have to fit the slide, okay, and you have to understand it. And actually, this generates something like OPCodes can be about 3 times heavier in long than the corresponding PHP code, okay? So I have to to design my slides to take care of this parameter as well. So this is an example of PHP code, which when you compile it, you will have something which will look like this. This has been dumped with VLD in console mode. This is why it's written in. This is a screenshot of the console. We have another extension which can represent this in pretty nice HTML with JavaScript, and you can hover with your mouse and it will pop up things. This is called explain, if you want to know. So I undercolored the corresponding things in OP. Okay, so if you look at the isSet structure, isSet is not a function. Okay, because if it would have been a function, it would be something like do function call, prepare function call. isSet is a special handler. Okay, it gets compiled to something which is not called the function isSet, but do this specific code which is hidden behind isSet is empty dim obj. So isSet as is empty. So you will have guessed that you use empty or isSet. It's exactly the same in the underlayer in the engine. It leads to the same opcode. So this is actually the opcode and the handler which is used, the parameters, the return value, and we have something which is called extended value, because is it an isSet or an isEmpty? How can we know at this time? We put something which is a flag in extended value, and we just have an if which tells us if it was an empty or an isSet. Okay, so you have two operands, and it gives a result. And the result usually is used as a parameter for the same, for the next OPCode, which is a jump, which says, okay, jump if this variable is 0, jump to the line which is number 7, which is fetch constant, which is just the if structure we have over there. Okay, it's not pretty hard to understand. This is compilation. Okay, so when you compile the code, when you run PHP code, it just compiles and then executes. It will execute all this. So the more code you have to parse, the longer the compilation phase will be. And the more OPCode generated, usually it's not absolutely right. Okay, usually the longer the execution will be. Okay, if you have 1,000 of OPCode, yes, sure, if you have a jump which says prevent all this, it's not fair, but usually the more OPCodes you have, the longer the execution will be. It's not really true, but anyway. So the more code to parse, the longer compilation phase. No problem, OPCode caches the compiled OPCodes in shared memory. Okay, so the first thing you do when you deploy code usually is you put your code to production and you just prevent users from fetching your server, and you fetch your pages with a curl or something like this. So you trigger the compiler and you make PHP compile all those codes, all those PHP files into shared memory. And then after, when it's in shared memory, after the first request on, say, the index page, for example, after this, you can open the server and people will come, and then your server will handle request, and then you will not have to parse code anymore. You will just have to load the OPCode from shared memory, which is a process actually very fast. Okay, and then you execute again, until your files actually change. So next, deploy. So the compilation is taken care of. Okay, OPCode cache will just cache the OPCode. So compilation is not a problem anymore for us. The second problem is execution. Execution can be long. Okay, it can take time. So some opcodes are heavier than others. Yes, sure. When you do, for example, when you do a function call, it's absolutely amazing how heavy a function call is for the PHP engine. Even with all the caches we've been adding in PHP for years, when you call a function, and a method is exactly the same thing as a function, okay, just get a this pointer in it. It's absolutely amazing how long and how heavy this can be for PHP. at the opposite, when you do a shift, you know, with the bracket signs like this, it directly leads to a shift in C, which is compiled by GCC pretty much right nowadays. So this is an OPCode which is pretty fast. Okay, so you have OPCodes which are heavy, long to run, and others which are faster. So Opcache is an extension that you can activate, which is available starting from 5.5. It's merged into PHP source 3 as an extension. Okay, so it's bundled with PHP, you have nothing to do. And before 5.5, it runs for 5.2, 5.3, and 5.4. I did not put 5.2 because 5.2 is just end of life. It runs as well for 5.3 and 5.4, but don't expect it to be as efficient as with 5.5 and 5.next, because when we add new optimization nowadays, we just don't care about old PHP versions, sorry, okay? From Zend, because Zend are nowadays the main contributor to this code, even if it's open source, they've been owning it for years now, so they pretty much know it. When I talk to Dimitri, which is the main developer, and say, oh yes, we could optimize arrays and things like that, yes, but it will only be for 5.5, at least 5.4, but 5.5 and next, because the next optimization are very hard sometimes to put in old PHP versions. But anyway, it still runs pretty nice with 5.3, 5.4. If you want to use it, you have to use it from Pico. It's both a cache and an optimizer. So let's now see how the optimizer comes to play and what it does actually to your code. So the role of the optimizer is to optimize the OPcodes so that when they will be run lots of time, then if we can earn a little microsecond, as we bet your code will be run again and again and again. This is a web server, okay? This is PHP. You have hundreds of PHP processes. Those little optimization will get multiplied by the number of times the code will be run, and then you will experience at the end of, let's say, 24 hours, you will experience sometimes lots of improvements when you stick all the little improvements together and then you run them again and again. So this can happen to be very tiny things. Oh, why do you just optimize these little things? But yes, we are looking at very heavy loaded servers with lots of PHP codes, frameworks, and things like that. So this is pretty nice to optimize every little thing which is worth optimizing. We do it. So examples. I don't know if you can really read from them. I could not just my slides. Anyway, you will have those slides after the conference and in PDF somewhere on the web. So if I told you this is silly code, but still we can meet it, this real code. This is a code with an if-false branch, which is, I know, silly, but if false just generates something like if false is false, jump to 3. If not, you're still okay. When Opcache comes to play with the optimizer, it optimizes it like this. This is just an echo statement, and that's all. And you always have a return, okay? Because the engine always returns something, okay, and you can change it. By default, it returns 1, but you know that you can return something and then include a file, and the return in this file will be fed where you met the include statement. So by default, if you do something like $A equals include something, by default, $A will be 1, except if your script has a return statement. So this is pretty easy optimization. This one is pretty nice as well. So PHP does not do this by default. Okay, if you don't use the Opcache optimizer, it will not do this. So here, on classical compilation, you can see that $A is 4 plus the string 33, okay? So you have to add the string 33 string to the integer 4. You put this in a temporary variable that you assign to a real variable, which is $a, and then you echo it and you return, okay? What Opcache does by optimizing this, it detects that 4 plus 33 can be resolved at compile time. And you don't have to compute this again and again and again at execution time. And it simplifies this by directly putting the computation. It figured out that 4 plus 33 is, yes, 37. And then it directly assigned the 37 the result. Okay, so when the virtual machine, when your script will be run, it will always assign 37 to your $a, and it will not run the addition anymore at every time. Okay, this is another optimization. This one is trickier, even if I guess you already got it. It seems like we, at the number, yes, not the same number for the temporary variables, anyway, 0 or 1. The difference here is that 42 string has been turned to the 42 integer by the optimizer. And turning a string to an integer is not transparent. It takes CPU cycles. Okay, so if you have to turn the 42 string to the 42 integer every time at execution time, at least when you have lots of requests and lots of codes everywhere, this is once again an optimization. So you can see that at compile time, we can only do what we are sure it is. If you have a if false, okay. If you have a $a equals false, if $a, we cannot do anything anymore. Because someone can change a by using a global variable somewhere. I don't know when people do tricky things with PHP, but we allowed them to do this, so that's our fault actually. And we cannot do optimization if you have too complex code. This one as well, it's been talked by Davis in his talk this morning. Having $i equals $i plus something, it's turned to an assign add, so it's turned to a $i plus equal 42, which is more optimized, because when you use an addition, you have to create a temporary variable and add those variables to a temporary one and assign it back to your variable. When you use a plus equal, it does it in one OPCode, which is called assign add. Okay, if you don't use this and you have this code, it will add temporary variable result, assign the temporary to the real variable $a, destroy the temporary, which is free, which is freeing memory, which is touching memory, and touching memory takes time. Okay, so we prevented this by turning the assign to assign add when we can. And this is the same, and Davis talked about it this morning. When you have the plus, the post-incrementation and the pre-incrementation, you know the difference in PHP is that the post-incrementation will create a result, okay? It will create a result, and if you don't use it, it has to free it. So that's a complete waste of time, memory, CPU cycles, okay? If I put $a equals $j plus plus, I get the result of the plus operation to a variable, so it won't free it, it will assign it, okay? But anyway, when the engine can turn a dollar something plus plus to a plus plus dollar something, and it does not change the meaning of the code, all right? We do this, okay? Because when you have a pre-incrementation or decrementation, exactly the same. When the signs are placed before your variable, the engine use a pre-incrementation opcode, and this does not returns any result, any value. So we don't have to create a temporary variable in the engine and free it after. So it's done automatically by the optimizer. This one is much more tricky, and it involves you that you know the internal structure of the engine. Well, what it does here, all the dollar something here, dollar plus a number, are temporary variables in the engine, okay? And what it does is that when you try to fetch the same array dimension and things like that, it tries to reuse temporary variables from before. Here, you can see that you only have two temporary variables, which are $0 and $1, and here you have $0, 1, 4, 5, and after you have another temporary one, which is a little bit trickier with the tilde, and it tries to optimize this so that it does not have to create temporary slots in memory, put things inside, and free the slot. Next opcode, temporary slot, free the slot. It tries to reuse slots whenever it can because it's pretty much complex internally. So that's another optimization which is done by the engine. This one as well is a classical one, which is called compile times constant substitution. You declare a constant, okay, const foo equals the string bar, and then you echo the constant foo. By default, the PHP compiler will say, okay, declare a constant, fetch back this constant to something which is temporary, and echo it, okay, which is pretty useless, because what you can do is declare your constant. Yes, you still need to declare, but instead of fetching it back and echoing the result, just declare it and get the result and put it to echo, and you save one fetch constant OPCode. This is little, but as I said, if you have lots of classes with lots of constants inside and lots of code, sorry about this, and lots of code, when you have little microseconds or milliseconds and you add them to lots and lots and lots of run, optimizing the OP array is heavy, but because this has lots of whiles and ifs and things like that, but this is done at compile time and you don't care about compile time. This was snippets of codes I took from the optimizer, which has just the visible part because Opcache takes care of lots of things for you. I can't tell you because even me, I don't master them yet. Optimizing compilation is something which has been written articles for years now, because we don't, before compiling PHP code, we compiled C code to machine code, so we know about compilation. So you have a pretty nice article in Wikipedia, and I'm looking for adding much more optimization in loops invariant motion, for example, which is a pretty nice thing to add, but pretty difficult to add as well. And Opcache does as well very heavy to compute things when you have lots of whiles, ifs, switch, break to, continue one. It tries to graph all the path, all the possible paths, and try to merge some path in the virtual machines so that you have a better code and better jumps in the virtual machine, all your ifs and whiles and things like that. So it's pretty interesting to know as well. Intent string optimization is also something. So this is a big text. I shouldn't have put it here, but anyway, now I think you just finished reading it, or 10% more, and that's it. You finished reading. Intent string is pretty interesting as well. It's been added to PHP 5.4 compiler. It says, okay, when you compile something, you meet strings, and those strings, you will need them later. The class string, we just don't care about it, but the foo is the name of the class, the bar is the name of the function, and etc., etc., etc. Every time PHP meets these, before 5.4, it just allocated many, many slots in memory to put all those strings which are all the same. Okay? Why can't we optimize this to have all the strings still pointing to the same pointers, like this? This is a very nice optimization. It's been added to 5.4. No Opcache needed, nothing like this. Okay, so that's why that's one part which explains why PHP 5.4 is has a much less memory footprint than 5.3, 5.2. This is one of the tricks. If you use lots of classes and lots of text and things like that, you can expect lots of optimization. What does OPCode, Opcache do? Don't care about this. Is that when you have lots of PHP processes, they all have their own intent string buffer. What Opcache does is that it shares it in shared memory for every, PHP CGI or PHP FPM child, so that they open all the same shared memory hole, and they all compile their code and read their strings inside. So this is pretty nice if you have lots of PHP workers. I guess you can expect a huge memory saving if you have a Symfony or Zim framework application with lots of classes and functions and things like that. What's the API of Opcache? Well, you can read it on the documentation. Okay, so I won't repeat the documentation, even if that's what I'm actually doing here. You know APC, so you can expect the same thing. We have a pretty nice as well. You remember the APC front end, which was graphical front end showing you the memory, etc. We have the same for Opcache. You can fetch it from Rasmus Ladorf GitHub repository. It has designed this with JavaScript and things like this. So what you have to know about Opcache is the settings. It's the same for APC. Memory consumption is the size of the shared memory segment. You should always have enough memory. If you don't have, PHP will just lag and will just start crashing and things like that. So have this huge enough. Max accelerated files is the number of keys, which is not the same as the number of files, to store in the cache. Classical Symfony 2 application needs about 3,000, and by default it's 2,000, so take care of this as well. And this is the explanation of all the statistics you can expect. They are not really hard to explain, so I will let you read them on the documentation, or perhaps directly on the front end here. What is a little bit tricky is number of cached keys. I have just to explain that. What are keys? Because Opcache does not cache. It caches files, but it caches them in a way which is a little bit tricky. You have to know about. A file foo may be accessed in your script by several paths. Okay, you can have relative paths, absolute paths, and things like that. Every single way of accessing a file, we create a key for this file. Okay, so that's the trick. The foo script actually will be stored once in the cache, but it will generate here 3 keys. Okay, so don't be mistaken with the number of cached scripts and the number of cached keys, which are all the different ways to access all the different cached scripts. And this is the cached keys, which is bounded, limited by the ini settings. So you have to take care about this, not to exhaust it. And as you can expect, validate timestamp. Should I check on the disk every time if your file has been modified? I did not experience lots of slowness when you put this to true in production, because nowadays Linux kernel are very nice to optimize those accesses as well. So it's not that bad having this to true in production. And the wasted percentage, I will talk to you about this in a minute. So those are settings you can read on the php.net documentation. So the cache, there is something which is tricky in Opcache. If you compare it to APC, it's that whenever you have a file, okay, it gets cached, and then it's going to change in production. I don't know why it's going to change. So Opcache is going to recompile it, but it will never free the memory of the old file. It will say, this is wasted memory. Wasted memory is memory allocated for scripts which are not up to date on the server actually, but the old memory is not freed, because if we have to free it, we have to reassemble all the blocks, and this is too CPU intensive. Okay, so when the cache is full, you have to trigger the max wasted percentage, and when it's reached, the cache will be restarted, and then it will be freed, and it will recompile all your file. This is a little bit tricky, you have to know about. So this is another example where we have a cache which is actually full, only 26 kilobyte free, but the wasted percentage is actually 5.07, and here it's under the 10 or the 15% in the configuration, so the cache will never be restarted. Okay, so this is pretty bad because it's full cache. So never have a full cache in production. It's absolutely horrible. Why restart? This is why the Opcache restarts actually. Out of memory restarts, hash restarts, or manual restarts. Those are explained here, so you should know the difference between them. The documentation is not really accurate about this, so I explain them here. So that now you know about those numbers. Know what happened. Opcache can have a very nice log as well. What it does, I'm compiling this script, I'm adding a key for this script, I don't have memory enough, I'm trying to fulfill this table and I don't have memory. You can actually have a pretty nice log as well for Opcache, which is nice. And last settings, and actually last slide, which is about things like fast shutdown. I experienced something like 1% or 2% maximum improvement, turning this to true. So you could do it. Consistency check is just something which will compute, figure out a sum with CRC algorithm to know if your file has been corrupted on the disk. Just don't use this. You can experience pretty much slowdown, 5–8% slowdown. So. Do's and don'ts, please have enough memory, fill in your cache before opening your servers to people, because you will have too many people accessing the same files every time. Every time Opcache accesses the shared memory segment, it locks it, so every process is going to wait for the lock to be released by the other processes, so try to be smart. It works like APC did, with little bit things which are a little bit tricky, and it at least as well adds a pretty nice optimizer. This is what you have to know about Opcache, and we are planning to merge its code to the PHP code in the next PHP release. Should it be perhaps PHP 6 or something like that? So actually, it's an extension you have to set up for. Please do not set up Opcache together with APC. It's not that. Do not activate Opcache together with Xdebug, okay? Because they both redefined and execute. You can expect pretty strange things. Opcache is something which is production. Xdebug is not, and you know that you must not have more than one OPCode cache at the same time in PHP, because it's going to be hell for you. And that's it. I guess we have something like 10 minutes actually for questions, so it's pretty nice. Thank you for listening. I'm taking questions if you have questions. So yes, I saw one here.
You mentioned there's the compile time. The compile time. Sorry, let me get this straight in my head. Is there an overhead the first time that it's hit? You talk about priming. What is that compared to without the OP cache? So you mentioned like 25% is compile time versus execution. How much does that add to the first hit? Does that make sense?
Well, the first time you hit the file, it will compile it, store in shared memory when you use an OPCode cache and execute it, and the next time it will just execute. So the 20% here is just an experience from I don't know which file or thing like this.
Is it marginal, I guess, is the question. Because it's optimized, and is it quite intensive to do it that first time?
Yes, yes.
Is that why you're recommending to actually prime?
Oh, yes. You should. You should. Even with APC nowadays, you cannot, you push new code and then you open your server. Everybody's going to hit the compiler. It's going to, the first one, which is going to lock the shared memory, and it's going to compile, and this is quite long, and then execute. So what you usually do is push code and then hit with curl. This is an example which is pretty much used everywhere and very easy. You trigger a web request to your main page or to all your pages or lots of them, so that all the PHP code is compiled, and you can feel it, even from a human point of view, that the first request, finally my result, and the next ones are pretty much they go faster.
Just lastly, you mentioned intern strings. Is that in 5.4 or 5.5?
5.4.
And you can use Opcache with 5.3.
Yes.
Do you get that benefit from Opcache? Does that do that optimization for intern strings, or does that only apply for 5.4?
No, Opcache detects the version of PHP it's actually being run on, and if it detects it's PHP 5.3, it will just disable all about intern string, because you don't have intern string in 5.3. So you don't have to care about the version. You just put Opcache and it detects itself and it activates itself what it has to do for the engine.
Thank you.
Another question here?
Hi, actually I have two questions. The first one is regarding the size of the memory. You mentioned that an average Symfony app, it had like 2,000 or 3,000. I was wondering, how do you calculate those numbers?
Well, just you have stats.
Okay.
And the function is Opcache gets status. It returns an array with all these, which are here presented in a pretty nice front end.
So you can monitor it in runtime and then check the numbers.
Yeah,
okay.
You just check. It doesn't matter which server, which thing. You set up your application for production and you run it, let's say, for example, locally on your local machine, if it's the same version, etc. And you just see how many files, how many keys. We usually did this when we on the machine when the user tests are run, with bhat and testers, human testers, which test the application on the testing machine. And this machine actually served us for statistics, for production sizings. So about that.
And the second question is regarding the change files. So you mentioned that when a file is changed, that has an overhead. So I was asking you, what is the best practice? When you deploy a new version of many files, you make like requests for those, the URLs that's going to use those files to cache
usually
them?
it's not one file, it's the whole application that you push another version. So
but what do you make to make requests for the common URLs?
What we did, in my experience, we trust Unix, so we all do everything in shell scripts. And what we do is, when we want to deploy, we start a new pool of PHP processes which are just fresh. We push the code in it, and we use a load balancer for fast CGI in Nginx and Lite. So we don't have to push and to change symlinks and things like htdocs. We just switch, we tell Lighty, okay, now the fast CGI pool is not this one, it's this one. And when it's done, we kill all the old process. We all do this with bash shell scripts and, you know, lsoff, kill, pid, or things like this, which has been working for 50 years now, and we don't trust tools. We trust what actually works, and what actually works is Unix, you know, Linux and GNU. So we use this, and we have never experienced anything which is wrong. We just have several PHP master pools with lots of children. We have 1, 2, or 3. This is the current one for production. We are going to release our new version. We push code to the middle one, and we say the web server, okay, now switch. So yes, you can have, and we let the old requests end until the PHP process says, okay, we ended, and then we kill each other, and then we kill with a sick kill the last runs. We just don't want to kill themselves, and then we prepare a new pool, and we watch like this. It just works. It's not very nice to use. In Opcache anyway, if you change files, you're going to waste more and more memory, okay, until it restarts, and when it restarts in production, your server's down. Well, I guess it's a heavy loaded server. Okay, so that's right. Yeah, another question? Behind you, yeah.
Hi. So do you think after all those optimizations, is there still much room for improvement without breaking backwards compatibility? After having working with all those Opcache that you have described? Do you think there is hope to be so much faster, or like?
Yes, there are still many things to do in PHP, so yes, there is still scope to optimize things, yes. Particularly in Opcache, I have lots of ideas, but Dimitri told me, it's going to be tricky, you're going to experience lots of bizarre things. So, for example, the arrays and the static arrays are something which is crazy in PHP. If you have a static array with only statics inside, only strings, mixed with integers, no objects, no other array, declare the array as static. It's a huge optimization for the engine. And Opcache can turn this, but actually it's not implemented. I'm working on this, but it's pretty hard to do. Yes, another question here.
It's regarding the keys you make. Why not just canonicalize the path and then you only have one key?
Yes. If you access a file in always the same way, you will just have one key for this file. So it's your role to take care of this. If you just don't want to have many keys, but you can expect something like ISO. I expect something like three keys per file. It's an average, which is.
You mean those keys are only generated when you actually access the file in a different way?
Yep.
Right.
Like this.
It doesn't calculate them in advance, then.
It doesn't calculate what?
The different keys.
The keys are calculated with the way you access the file. So if you access require a.php, require point/a.php, required point/point/point/a. This is a third key. This is, yes, you can shoot your foot. No problem. So yes. But usually for every PHP application which is normally designed, it just works. It just works. You see, on this example, which is, I don't think it's a production example, but it should be something like a Symfony 2 application. We cached 1,800 about scripts, and we have about twice the, it's a little bit less keys, so it's all right. Yeah, another question over there, and here.
Last question, please.
Last one, yeah.
One of the problems with APC was that if you enabled APC for CLI as well, it didn't actually share with your web servers cache files. Does Opcache actually share code, the cache code in shared memory, so that it's available to both CLI and web access of pages or of scripts?
Well, CLI is not the same thing at all than web context. Nowadays, it's FPM we use, so Opcache has the same trick as APC, which is opcache.enable CLI equals 1, so it enables in CLI, but it cannot share the same segment. It's not the same PID, it's not the same process, it's not the same process tree, you cannot share. This is anonymous mapping for those that know. This is mmap, map anonymous, so you can only share in a parent-child relation under Unix process. So you have all your you have your FPM master, your FPM children, and then your CLI. That can't be shared if we don't use a file, and we won't use file backed mmap, which is bad for security. So no, that's the answer. That's it. Okay, thank you.